Slope field? What's a slope field? It is a field that represents the slope. Well, that clarified nothing at all. It represents all the possible solution curves. Okay, you're going to see where this is going in a minute, but in the meantime, let's just make a slope field. First of all, let me grab a paperclip, and talk about various slopes. This is a slope of 0. This is a slope of 1. This is a slope of -1, assuming a scale of 1 to 1. This is a slope of undefined in a vertical sense, like we divided by 0, but it wasn't 0 over 0. This is a slope that is a little less than 1, but between 0 and 1. This is a slope that is slightly negative, but not quite -1. These are steep slopes. These are negative steep slopes. Hold that in your head. Okay. Put the paperclip, don't hold the paperclip in your head, that would be painful. But what we're going to do is plug in an x value into this and crank out an answer. So they're going to be doubled basically. So at the point 0, 0, I'm going to plug in 0 for every x, and I would say I'd plug in 0 for every y, but there are no y's. Okay, so 0 for every x and 0 for every y. So 2 times 0 is 0. So my slope here is 0. Okay, here at the coordinate 0, 1, I will plug in 0 for every x and 1 for every y. I don't have any y's to determine my slope. Here's what's really happening, okay? If you really want to see all the little work that I'm not going to show every single time, but this point right here, 0, 0, was dy dx evaluated at 0, 0, which means I have 2 times 0, which gave me 0, which means it was a flat line. Okay? And then I'm going to say, oh, well, let's move up a notch. So dy over dx evaluated at 0, 1 is really 2 times 0, which is 0. Oh, wow. Okay, you can see a pattern here. If I plug in 0, 2, well, there's nowhere to plug a 2. So 0, 0, 0. Okay? Check this out. I'm going to plug in 1, 0, and I'm going to show a little bit of work on this one. We are not going to do this for all 25 points. That's just excessive. Plus, I need some space for some other things as well. So dy dx evaluated at 1, 0 would be, well, I'll plug in a 1 for every x and a 0 for every y that I don't even have. So 2 times 1 is going to give me 2. So I'm going to represent the slope here with a tiny little mark that shows, well, the slope here. Just like I represented these with a tiny little slope of 0. This is a tiny little slope of 2. And you know the pattern. If I plugged in a 1 for any x, I would have a slope of 2. This is about a slope of 2. Well, how do I know if it's here or here or here? Don't panic. Just what does it look like? Does it look a little more than 1? Go for it. There's that. There's that. There's that. There's that. They're all the same. They should be. They don't look the same, but they should be. Then if I plugged in an x value of 2, it would give me, well, 4. So 2 times 2, of course, 4. So even steeper, hard to tell, but a little bit steeper. Okay? So for all of these x values, we're going to plug in -1. Plugging in a -1 gives me a slope of -2. So here's a slope of -2, -2, -2, -2. It's an estimate, doesn't have to be perfect. And then plugging in -2's for x gives me -4, -4, -4, -4, -4. Okay, we haven't even read the full question yet. Sketch the slope field, done. And before we move on, let's make sure we understand what it means. This is the slope at any given point. That's what a slope field is. For all of our solution curves, you'll find out what that is in a second, that's our slope. Sketch the solution curve, the solution curve through the point 0, -1. Okay, solve the differential equation for y. I think I can do that too. So I'm going to sketch the solution curve through the point 0, -1 using a purple pen. Okay, 0, -1. I'm going to follow the general trend of this. So it's kind of flat, but clearly it's starting to kind of turn up, and then it goes up, right? So then on this side it would go, well, I can't just keep it going flat. I'd run into this line, so it's got to go up. So here is a solution curve through 0, -1. There we go. How do I know it hits that point? You'll see in a minute. And then we'll come around this way. And we can see that it follows the general trend, which is why this slope field works. It looks like a parabola to me. You want me to prove it to you? Check this out. Check this out. It's beautiful. All right, I'm going to doodle over here in the space that I have. This slope field represents the slope at any given point. Well, slope of what? The slope is 2x. But then the answer to the slope of what? Let's move the x to the other side. We're going to do a thing called separation of variables. We're going to bring the x up, keep the y where it is, and dy equals 2x dx. It's like multiplying by the denominator to move it to the other side. It's the same idea. So whatever you do to one side, you do to the other. If we integrate this side, we'll integrate this side. Okay, let's do the right side first. The integral of 2x, the antiderivative, indefinite integral, meaning I don't have numbers there, would give me x squared, and then plus c, right? Okay. The antiderivative of 1 would be, well, I would say it's x, but it's with respect to y, so it's y. And then you'd say, oh, plus c. Yeah, don't. Don't put a plus c on both sides, because even if you had a constant here and a constant here, they would be like terms and you could move them together. We don't know what the constant would be here and what the constant would be here, but we'll just put them together and call it a constant, okay? This is a parabola. X squared, check it out, plus c. C is, we're going back to some like algebra 2 type stuff, translating a graph. This would be my vertical shift. So this particular solution curve has a c value of -1, and we can draw through there. If c equaled -2, we would draw it down here. Either way, we're always going to have a parabola. This follows the general trend of what's going on.